The Mars Curiosity landing was a very exciting time. That is our Super Bowl. It's our Olympics. And we have to figure out, it's our, we don't get that many moments in the sun, so we have to figure out how do we share this amazing experience with the public. So 9 years ago, the Mars exploration rovers landed on Mars, and we broke internet records. This time, it was an even more complicated piece of machinery, the weight of about 2,000 pounds, and about 150 million miles away for a pinpoint precision landing. So how do you estimate the traffic? Well, we knew it was going to be big, and we knew we didn't have the technologies in-house. We couldn't build data centers big enough. So 5 years ago, we started experimenting with cloud computing. And cloud computing had a very strong possibility of working for us. So we decided to try it for the cloud. We worked our way up to get there. And once we discovered that we could actually use it, we sprung into action. So what we did is we partnered. We had a competition, and we ended up partnering with Amazon Web Services. And we had figured out that it was actually useful for missions and very, very cost effective. We had, on the road to there, we had 180,000 images from Cassini that we had to do some image processing on. We had already done cloud computing on games and websites, so we thought, could we actually do it in the cloud? And we did it, and it finished. It had been running for 15 days, day and night, when we stopped in the lab, ran it in the cloud, and it finished in 5 hours for less than $200. So then we said, okay, this could be cost effective. So the big Olympics, the big landing, our Super Bowl, Mars Curiosity landing. It's about a year ago. So we partnered with Amazon, and we built out the infrastructure so that it could scale. The key here was that it was absolutely mission critical. It had to work. So we structured it in such a way we could have lost all of the East Coast or the West Coast, and we could have tripled the traffic, and we would still have been okay. So what happened, we looked at, as this traffic was coming in, we had commands, and we could increase by 25 gigabits per second with a 30-second lead time. So we would watch as the traffic increased, and it really started spiking. We turned on more and more. We thought we would need to get to perhaps 50 gigabits per second. We ended up at 150 gigabits per second. So it was actually more popular than the Olympics during that event. And we hoped for a soft landing of the spacecraft, which we got. We also hoped for a soft landing of a web server, which we also got. And then the good news about economics is once the traffic started dying down, once it was successful and all that, and people went back to watching the Olympics again, we were able to start shutting off that infrastructure, saving money, as opposed to having it in our own data center all the time, having to pre-provision it. So when everything was said and done, we were able to deliver 150 terabytes, 80,000 requests per second, 150 gigabits per second. And we did it 100 to 1,000 times more cost effective than we did 9 years ago. And people were able to see those wonderful pictures from Mars exactly at the same time as we did it. So great success, and we have continued using cloud computing, and we just shrunk the infrastructure, and we've reused it several times as the new events happen. So quite cost effective, and most important, people were interested, and we got to deliver the pictures.